Hello and welcome to the Erlang Solutions monthly webinar. My name is Mladen Miliksic and I'm the VP for the EMEA region here at Erlang Solutions. Today's webinar represents a continuation of a series of webinars we have been running across topics of interest in the world of Erlang and dealing with solutions based on the Erlang programming language. Today's webinar will feature Virtual Hold, an Erlang Solutions customer who has used Erlang to reduce call center operation expense by virtualizing customer hold time. We will hear a bit about how Virtual Hold has leveraged Erlang's capabilities to provide fault tolerance and client multi-tenancy across a cluster of servers, as well as provide a primary and secondary failover configuration, allowing for seamless transition of phone calls in the event of a hardware failure. Now, as with any live event, please do excuse any technical issues that we may face. But to start by telling you a bit about Erlang Solutions, we are a products and services orientated company devoted entirely to the Erlang programming language. Since our start in 1999, we have worked with organizations and individuals using Erlang, helping evolve the language and supporting people and businesses using it. Nowadays, we have just over 100 people sitting across our offices in London, Stockholm, Krakow, Budapest, Seattle, and most recently Buenos Aires, and working on projects across the world. We provide services around the Erlang language, such as code and architecture reviews, Erlang language training, Erlang consultancy, whether on customer site or remote, and support of Erlang-based systems. We also develop Erlang-based products, and some of those you've probably heard of, such as Mongoose IM, which is our open source messaging platform, the React distributed database, and Wombat OAM, which is our monitoring and management technology for Erlang systems, as well as many other solutions that are applicable in areas where Erlang makes sense. I'm really pleased to say that our speaker today is Brian Ward, the principal software developer at Virtual Hold. Brian has been developing software professionally for over 22 years now, and in the course of those years, he has worked for companies small and large alike, such as AT&T, for example. He has worked with Unix and Unix-like operating systems, as well as the ubiquitous Microsoft Windows platform, and primarily with languages such as C, C++, and Java. He's also tried his hand at management, and during all this time, he did not write a single line of functional programming before learning Erlang in 2013. Currently, Brian works with Virtual Hold technology and spends a lot of time actively mentoring younger members of his team in the arts of agile software development and, of course, Erlang. Now, please allow me to finish by saying you're very welcome to pose questions throughout the duration of the webinar by using the chat facility on the webinar's interface. We will pick those questions up at the end of the webinar, and our speaker, Brian, will answer them at that time, as time allows, obviously. If any questions do go unanswered, you're welcome to raise them via email using the following address, webinar@erlang-solutions.com. If you are interested in learning a bit more about Erlang as a language, or simply wish to discuss whether it could be a solution for the challenges your own business may be facing, then by all means, feel free to contact myself directly. My email address will be displayed in one of the final slides of the presentation we will share with you today. I would now like to hand over to Brian, who will be glad to start us off.
Thank you. Hello, I'm Brian Ward, and as was said, I'm a principal software developer here at Virtual Hold Technology. We're in Akron, Ohio, in the US. I have been developing software professionally for about 22 years now. I've been at VHT for the past 4 years. And today, I'm going to tell you a little bit about the experiences we've had with Erlang and with Erlang Solutions over the past 3 years. To give you an idea of what I'm going to try to cover, I've included this slide. The first half of the presentation is background on VHT and what we do, background on our decision to experiment with Erlang, and background on our commitment to Erlang and our engagement with Erlang Solutions. The second half of the talk will cover the various projects we've done with Erlang, how those projects have increased in scale and complexity, and how those projects have leveraged Erlang's strengths to make real bottom line impact here at VHT. And as Mladen said at the beginning, there will be time for questions at the end of the presentation, but that doesn't mean you should wait till then to begin thinking of your questions. Please feel free to enter them into the webinar chat anytime during the presentation, and we'll get to them at the end. So who is Virtual Hold? We are a 20-year-old software company that puts us about the same age as Erlang Solutions. We specialize in telephony applications. We have a headcount of about 100. As I said, we focus on telephony applications targeting the call center market. There are two things that make us interesting to talk about, I think. First of all, we're located in Akron, Ohio, in the US, and Akron is a relatively small metropolitan area with a population of just under 200,000. We are about an hour south of Cleveland, which is about twice as large as Akron. But all in all, there just aren't a lot of people around here. The landscape, especially as it relates to talent acquisition, is radically different than what you might find in London, Stockholm, San Francisco, or other tech hubs. And that complicated our decision to move to Erlang. Second, our embrace of Erlang coincided with a transition into an agile methodology. The agile shift began a couple of years prior to the introduction of Erlang into our shop. During that time, we had become accustomed to the concept of constant process improvement. We had mastered, or tried to master, the art of identifying our own shortcomings and trying out adjustments to see if they had a positive effect. Erlang was one of those adjustments and one of the successful ones. VHT has several products, but without question, it has one primary product, and that product is Callback. Callback is a service that allows callers to remain in queue for an agent, but to do so virtually. The software maintains the caller's place in the queue and will call them back at the appropriate time and connect them to an agent. If you hear, "We'll hold your place in line and call you back when it's your turn," then you're experiencing virtual hold. Callback was developed at a time when long-distance toll charges were significantly higher than they are today. The product was developed as a cost-saving measure for call center operations. By moving the caller into a virtual queue, the toll charges could be avoided. It was also very easy to show how virtual hold literally paid for itself. At the same time that toll charges were dropping, virtual hold was enjoying another kind of evolution. Not only were we saving the toll charges, but we were also saving customer time. Customers who didn't have to wait on hold are significantly happier than those that do. As a tool for customer retention, the cost-benefit calculation becomes a little more complicated, but is there nonetheless. And moreover, our uptime characteristics of our application became much more critical. We could no longer accept downtime as an isolated event. Now it had a more far-reaching effect. So in about 2012, we started looking for a solution to some of the platform instability we were experiencing in our C++-based callback product. Because of our shifting value proposition, moving from operational cost savings to customer retention, we needed to be providing a 24/7 service to become a true enterprise application. No simple task when you have years of code that was never designed for that level of reliability. So we were in the telecom sector. Erlang is in the telecom sector. And Erlang touts some amazing uptime characteristics. And even more exciting was the claim to zero downtime hot deployment of updates. This was the kind of thing our product was screaming for. But a switch to Erlang is far from a small, incremental, and measurable change that our agile tenants were calling for. Furthermore, our list of challenges around Erlang was non-trivial. We had no experience or expertise with Erlang. We'd need both if we were to accomplish anything. Everyone at VHT had been writing object-oriented code in C++ and C# for years. A change to any new programming language is disruptive, but a shift to a whole new paradigm, like functional programming, is somewhat earth-shaking. And additionally, we were in that small market. Finding quality developers is challenging. Finding quality Erlang developers is nearly impossible. And finally, our current product was, and still is, a Microsoft Windows-based application. And while Erlang will run on Windows, it clearly has its roots in the Unix world. The vast majority of tooling and deployment success stories seem to be around Unix. So we had to ask ourselves, was this really the right tool for us? We decided to do an experiment with Erlang, and to give ourselves the best chance of success, we found some experts to help us out. And those experts were the great folks over at Erlang Solutions. The engagement ran in two phases. Initially, Lucas Larson came on site to take a couple of developers into a deep dive with the Erlang platform. This was a lot like a boot camp approach, providing direction, taking them as fast as they could go to accomplish some meaningful and measurable success. This lasted a week or two, and after it was over, our guys presented what they had learned to the rest of the team. And they were the star witnesses at a big meeting with our VP and other senior management to decide the fate of Erlang. Well, they loved what Lucas had taken them through. They had a good fundamental grasp of the platform, and they had some excellent code to demonstrate. So the decision was made to go ahead with a second phase, to develop some actual production code, albeit on a small scale. Our first production application, first production Erlang application, was our Outbound contact client. This was an abstraction layer to support the need to initiate the outbound call you back portion of our callback product. Ultimately, we interface to a number of different vendors, and each one has a subtly different way for us to create the outbound call. So we designed and built an Erlang service to do this. The service would communicate with our core software over a proprietary TCP protocol and generate the outdial requests via a set of plugins that would handle the vendor-specific issues. This felt like a great place to start. The code was small and isolated. Further, It allowed us to flex some of Erlang's muscles. Certainly the async messaging applications are an undeniable strong suit for Erlang, and that would be what was leveraged to talk to our core product. A small team was assembled. The group from Lucas's training formed the core. Then we added a couple of new developers. And within a month or so, they had things working. Lucas provided some remote assistance during this phase. And during this first project, we were very intent on doing some test-first development. So we had to learn both eUnit and common test at least sufficiently well to get us rolling. Looking back, the success was everything we had hoped for in a small project. We became adept with some of the third-party tooling, and by third-party tooling at this point, I mean Rebar. Erlang did in fact deliver the uptime that we were looking for. Our design proved functional, no pun intended, and extensible. And we had something working very quickly, which was unexpected. But there was no success that couldn't be more successful. Our decision to isolate the Erlang team meant that we began building a silo around the knowledge. We delayed our internal education and acceptance by keeping the secret of Erlang locked in the heads of a select few. Also, in our ignorance, we spent some time developing code that really didn't fit the Erlang paradigm and for which there were already solid off-the-shelf options. One such example was our logging framework, which has since been stripped from the Outbound contact client codebase. It proved to be a performance bottleneck. In the future, using something like Basho's logger framework proved much simpler and helped us stay focused on the real work of delivering callback. The next project that we embarked on was the development of a REST API for the core callback product. For this, we created a whole new team, trying to tear down some of the silos we had found ourselves creating. Leveraging the same proprietary TCP code that we had written for Outbound Contact Client, we began working to extend the platform via REST and JSON, the JavaScript object notation, to allow modern clients to interact directly with the callback platform. We added Web Machine to the mix here, so we had something else to learn. And Web Machine pulled in Moki Web, so there was that. And Moki Web gave us Moki JSON. That gave us a library to handle the JSON to Erlang conversion. But of course, we still had to sort out the somewhat odd tuple and list structure that Moki JSON uses to represent the JSON objects. All those things were still very odd to us in the early days. There was probably more struggle that went into translating our RPC model into a REST model, though, than overcoming any particular issues with Erlang. We only spent a little time on the REST API before some shifting priorities put it on the shelf, a shelf from which it's yet to come down, but it was still a very valuable learning experience for us. When we retroed that project, a couple of positives jumped out. We realized we were getting comfortable with gen servers, and this was a big deal. When you reach that point with a new platform where you're beginning to embrace their paradigms, and you're no longer trying to bend the platform to your vision of the world, you've gotten to a good place. This was the first moment where we started feeling this way. We also really enjoyed working with WebMachine, and spoiler alert, WebMachine makes many more appearances in the future here at Virtual Hold. Having put together a couple of projects, we started to understand RelTool, and maybe understand is a bit misleading. We began to understand that it was really important and powerful, but we needed a lot more experience with it to really begin to understand it. At this point, it was kind of an all or nothing black box. Either it generated the release for us, or we got some cryptic error that made no sense to us. Then we'd have to go back and check our work and see if we can't try something different. This project also began to raise some questions with us regarding the readability of modules. The TCP message code was beginning to get very messy and hard to read. We began to worry about how to structure our code to maintain readability. With Erlang's relatively flat namespace, it makes sense to keep modules big, but big modules mean that the code is hard to find and hard to read. So the next big step for us was high availability. This was our biggest undertaking to date. Attempting to implement a high availability failover solution using Erlang, using NIF, using our existing C++ code base. And it was at this point that TTO came on site for his stint of the Erlang Solutions engagement. At a high level, we had to take a monolithic Windows service, create a wrapper to support cross-system messaging, to negotiate state, and to maintain status between the two nodes, and to keep the critical state data synced to the backup system. This meant that we had a bidirectional NIF interface into the C++ code, which was pretty complicated stuff early on for us. We utilized Mnesia to store state data, which simplified the coding to some extent, but came with its own baggage. This is where VHT really started digging into Common Test. The Common Test framework was a natural fit for the HA platform. Our design involved a number of different runtime nodes. So CT gave us the ability to write tests to span Erlang processes and Erlang nodes at test time. When we came out of developing HA, we had three big takeaways. We realized some of our developers were still hanging on to old OO coding paradigms. They were still trying to bend and twist Erlang to be more like C++. They were still trying to make OTP projects feel more like Visual Studio projects. They were losing out on some of the elegance and power of Erlang OTP because we weren't going with the flow, but rather fighting the current. And while others had generally gained a level of comfort with Erlang as a language, and even the paradigm of functional programming, a lot of the OTP features were still a mystery to us, especially the release process. We still really didn't understand what was going on with RelTool. Typing rebar generate into the shell seemed as likely to fail as succeed at any given time. We were also beginning to build our first real supervision trees in our OTP applications. when you first venture beyond that simple application to supervisor to worker model and into something more complex. But this was kind of the anomaly in the code we were writing. We didn't do it a lot. And our understanding of what OTP could do and how to use that to design solutions was still eluding us. But we were getting there. So we had some work to do. If we were going to find long-term success and happiness with Erlang, we needed to spend some serious time figuring out how we really wanted to be constructing these releases. What were our projects going to look like? And what were the repositories going to look like? What were our releases and runtime nodes going to look like? And what was our installation process going to look like? And what were we going to do to replace Visual Studio in our development and workflow? We were currently employing about half a dozen tools for code editing, and nobody was getting very good at any of them because we kept switching back and forth. There were a bunch of us using Emacs. There were a bunch of us using Vim. There were a handful of us using Eclipse with the Erl IDE plugin. There were several people using Sublime Text with its Erlang plugins. And some folks were even resorting to Notepad++ on Windows. We were all over the map. Our next project was the system management. So at the same time we were finishing up the high availability work, that team that had been working on the REST API was called in to develop a system management solution, something to control the HA functionality and report back on the status of various components. Now, this project suffered all the problems and shortcomings of its sister application, the high availability one, but it did introduce some new things that helped shine a light into some of the darkness. We built the Erlang part of this solution as a REST API. Having just come off the REST API project, it seemed like a natural choice. We built the user interface as a JavaScript single-page application, our first one here at Virtual Hold. And this set the pattern for the web UIs to come. We'd use Erlang and Web Machine to construct a REST API. Then we'd build a JavaScript UI over the top of it. Some other exciting developments on the Erlang front. In system management, we built our first distributed application using the application environment to tell the Erlang kernel how to manage distribution. We used a global name to help give us access to the distributed application gen server. And we also consumed a second REST API behind the scenes that our internal authorization and authentication service was consumed by the Erlang. So this solution really did set the pattern for a lot of our future applications. The whole Erlang plus Web Machine plus JavaScript formed the new formula for success. And it was also at this point that we began to standardize on using Bashow's logger as the logging framework. And just as the HA project was heavy into common test, this project was very heavy into eUnit. And between the two, it felt like we were really getting our hands wrapped around testing. So listed on the good side of the table here is the line showed the need for a real messaging platform. And that actually sounds like it might be a bit of negative to have shown that we needed something that we didn't have. But in the long term, it was a real positive. When we first rolled out system management, we relied heavily on Erlang messaging to get the notifications pushed around and into the system management system. But long term, we needed status messages to be pushed from all kinds of different components, many not written in Erlang. And that put us down the path of AMQP and specifically RabbitMQ. And we had talked about RabbitMQ here at Virtual Hold for years. In fact, RabbitMQ as a name, as a topic of conversation, predates the term Erlang in our design and architecture discussions. But it always needed a catalyst. And ultimately, the system management project became that catalyst. And then Manesia. So I really like Manesia. And when it works, when it's good, it's great. But when it's bad, it's a little disastrous. And you know those footnotes in the Manesia documentation that talk about needing the reliable and low latency network to support Manesia. Well, they truly weren't kidding. And we did experience a lot of problems in early production around Manesia. When we would deploy this at customer sites, we would discover that networks weren't reliable, networks weren't fast in all cases, and Manesia is where that showed up the most. So we had a lot of struggles early on, and we're still, to be honest, working through some of those. When is the right place to use Manesia? And where is the wrong place to use Manesia? So that brings us over to our configuration management project. This was the first of what I call our next generation Erlang projects. We had some time while VHT began rolling out the high availability solution to customers. We had time to think on our sins and time to experience the joy of supporting the brand new technology out in the field. And the time that wasn't spent healing network partition Manesia datasets, we began to look at the project structure we had employed in 2013 and came up with a better 2014 version. Starting with configuration management, we began to build projects centered around the node or the release. Still not really sure when to use which term. Individual applications would be in subdirectories beneath this and not in their own repositories. The whole node could be worked in all at once and as one. This really streamlined the process. The configuration management project itself was a huge delivery success. It was another Erlang plus web machine equals REST API with a JavaScript UI, exposing a lot of functionality that had laid dormant within the core product. we enabled some on-the-fly reconfiguration of some aspects of the callback system. We did two really cool things during this project, one of which had some far-reaching future direction implementations. First, I'll talk about eUnit. We really got into test generators in this project. The code itself made heavy use of higher ordered functions and closures, and suddenly eUnit's test generators didn't seem so foreign because they're also higher ordered functions. So we really began exposing some of the power and functionality that's in the eUnit framework that we hadn't seen before. And the second thing, and probably the most far-reaching and impactful thing, is we really began seeing some platform independence with configuration management. So for no particular reason, we began doing some of the early configuration management prototypes on Linux. The configuration management service was interacting with our core product over a network connection, so they didn't have to be running on, it didn't have to be running on Windows. So we started putting it together on the Linux platform. We began doing a couple early demos with the Erlang code running on a Windows server, talking to our core product running on a Windows server. At one point in time, we even did a demonstration of an early version of configuration management running on a Raspberry Pi on the Erlang distribution put together by Erlang Solutions that you can download, and that was successful. The biggest thing internally that we did was shift around the structure of how we were putting together our projects. We have this new and improved approach to projects where we would layer everything under the node. And when we have applications that are being packaged up into a node or into a release, we found that there were three ways that we could include them and incorporate them. The first was the way we had done it from the very beginning, where the application was a dependency managed by Rebar. In this case, it has to have its own Git repository. It has to be separate from the application, or I'm sorry, separate from the node or the release. This works really well if the application is completely stabilized, if you're expecting to interact with it about as much as you would with a third-party dependency. But it's really, really awkward, we found out, to be making changes interactively with an application that's included this way. The easiest way to include applications, we found, was just as a subdirectory. Maybe we'd create an apps folder inside of the project. We'd include the applications, the various applications up under that. There was no fuss when you were doing it this way. All the code was all in one place. The applications, the tests for the applications, the node, the release, everything was all built in one tree. Nothing was terribly complicated. The only downside to this was that the applications really couldn't be shared outside of this structure. For that, we went to using Git submodules. This formed sort of the middle ground between these two. With only minor management overhead, one extra commit and push inside the submodule, you'd wind up with something that was easily shareable, but also easy to maintain and develop with. And again, this is only necessary if you actually want to share out the application. So we had a few applications within our project, one to interact with a relational database. We had the one that did the asynchronous messaging back and forth to the core client. These we wound up implementing as submodules, and then we made all the other applications just subdirectories within the project. Another thing that we did at this point that proved to be really useful was beginning to create multiple release targets inside of the rel tool config. This enabled us to run a slimmed down version of the code in certain disconnected scenarios. If we wanted to test the interaction between the user interface and the API without necessarily interacting with any of the back-end databases, we could spin up a configuration of the node that didn't include any of the relational database code. This allowed some of our JavaScript guys to work from coffee shops where they didn't necessarily have access to the legacy databases. At this point, when we started doing things like that, we finally started getting to the point where we felt like we were understanding a little bit about what was going on in rel tool. And that was a big turning point for us. And now a quick word about our deployment, that is to say, installation. And I had avoided this story early on because it was hard to find a spot where it fit. But in the spirit of full disclosure, here's how we messed this up and then we recovered. When we built the installer for our HA release, we did some weird things for what we thought at the time were good reasons. We thought we have all these nodes on the system, and we might want to delete one of them and replace it with a new copy while leaving the others in place. Anyway, the whole problem with that is that when you've got all these nodes running on the system and it's a Windows system, one of those nodes is going to have fired up EPMD. And once EPMD is up and running, the file's locked because of the way Windows does memory mapping. You can't delete the file, can't delete the folders that contain the files, and so you can't easily drop in all the new stuff. So instead of figuring out how we might be able to use rel tool to support using the Erlang runtime from the system copy of Erlang, which we later found you could do, we instead decided to dump all of the libraries and applications that we were writing straight into the system Erlang's lib folder. In retrospect, probably wasn't too smart to have done this. And as if that weren't enough, after all of that, it turned out that the use case of replacing just one node on the system turned out to be pure fiction. We never ever did that. We always replaced everything all at once. So at this point, we backed off on trying to install things this way during configuration management. Instead, we went back to what I like to call the sandbox environment that rel tool kind of creates by default, where it bundles up all the pieces of the Erlang runtime that you're going to need and puts them in one directory tree for you to use. And we started pushing things out that way. So starting with system management, we were distributing all the core pieces of the Erlang runtime that we needed. We weren't relying on a system Erlang to have been installed, and things were much simpler. Another huge benefit that we got from this was that when we rolled out system management, we did it on release 16 of Erlang and a 64-bit version of R16. The earlier HA project had been done on a 32-bit version of R15. By using the sandboxed approach, system management could run under R16, and the core stuff, the main product could run under the R15 32-bit stuff, and they could interact over the network just fine. So while configuration management was getting built, another team was focusing on extending and revamping the parts of our system management. This is why the absence of needed message platform that we talked about earlier became such a plus. The system management team added RabbitMQ to the system footprint, figured out the whole installation and configuration process, and retooled all the components to leverage AMQP for status updates. Okay, maybe not all of them, but most of them, and it's still ongoing work. This was another huge win for the Erlang initiative. Here was a project that was getting actively enhanced and extended after its initial release. And at a small company like ours, it's the definition of acceptance. Erlang was becoming entrenched. We were starting to set the stage for the future. And here's the future. Well, maybe. We're currently building a prototype of callback for the cloud. We're calling it VHX, and it's all Erlang all the time. It's running on Linux, not Windows, though we're not actively crippling it from later running on Windows, if that's what you really want to do. We're heavily leveraging RabbitMQ for distribution of work across the cluster. We're also employing some new non-Erlang technologies like Elasticsearch and Nginx. Our work distribution scheme uses something we're calling workers because, you know, that name's never been used before. So we declared that a worker would be represented by an Erlang application. That made it fairly modular. It also allowed us to build a custom supervision tree to support our needs. At the top, we have a worker supervisor who's in charge of managing what we call the control gen server, and also a scaling supervisor. The control gen server listens to a special AMQP exchange that delivers messages specific to configuration of workers. The control gen server then acts on those messages to reconfigure the workers, mostly by issuing requests to scale the number of processes listening for work. That's the job of the scaling supervisor. It manages all the actual worker gen servers. It's a simple one-for-one supervisor, so we can easily scale up and down the number of worker processes. And all these modules are completely boilerplate. They're reused across every worker without any code modifications. They only take some slightly different parameters at startup time. The worker gen servers themselves are layered with a module that abstracts all of our protocol stuff, the way we've agreed to structure messages and handle returns and such. The custom worker implements a behavior, and the framework uses that to invoke it. We've currently implemented 3 kinds of workers into this framework. Our simple worker is AMQP based. It gets its work from a RabbitMQ work queue. We have an HTTP worker that's sitting atop web machine, We use the web machine framework to acquire REST requests, which we can then dispatch into the worker. The framework handles all the out of and back into HTTP drudgery, leaving the custom module free to focus on actually doing work. And we're also supporting something we call an automation worker. This worker is simply triggered periodically, not by any external stimulus, but rather by an Erlang timer message. This allows us to extend our worker framework to incorporate workers that aren't triggered from the outside. And one last plug, for VHX, we started using Travis CI for building and continuous integration, and it has been great. I can't imagine going back to doing it any other way. They have a wonderful, flexible system that does everything we need, builds triggered on every push out to GitHub, even on branches. And for every push, we get a compile, we get all our tests run, we get the generated release, we get test results and the release bottled up and pushed out to Amazon S3, where we can later go out, grab them, put them on a server for some real interactive testing. So here's the big disappointment for those of you who thought I'd be walking you right up to those gates of call center heaven that were in the invite. We're actually still on that road. It feels good. It feels like we're on the right road, in the right direction, and moving at the right pace. We're confident that we'll reach our destination in a timely manner, but for the real results of this effort, we'll have to stay tuned. And that is what I've got for today. So do we have any questions?
Brian, please allow me to, first of all, thank you for a very inspiring talk on what Virtual Hold have done with Erlang. And I'm glad to say that questions have been sort of pouring in quicker than we can hope to answer them. But just to say to our audience, because we only have, theoretically speaking, 7 minutes left, we will try and answer as many questions as we can on this particular moment of the webinar itself, and then obviously if we cannot answer, if any questions are left, we will answer them via email, so you'll get your answers. But just to start, so people have been asking a lot of questions in relation to the big sort of paradigm change that you've described in moving from one environment to a completely different sort of Erlang-focused environment. So I guess a theme that's been sort of moving through a number of questions is, how long did it actually take for people to become productive in Erlang, moving from a completely different mindset?
Well, it varied a lot. So we have our development group, programmers, is probably about 20 people, give or take. Of that, a handful, 4 or 5, took to this like fish to water. And it felt like just a matter of a few weeks, and anything you threw at them, they just chewed up. And it was like they were just meant to work on Erlang, and we're just waiting for a chance to. I think for the bulk of the people, it was a much slower transition. I think that our agile approach to software development, we do a lot of pair programming here, and we do a lot of test-first development. And I think that really helps spread the knowledge. But I think that when new people start working on Erlang for the first time, it takes them a couple of months probably to really start to fall into the patterns. And then, you know, there are actually those that simply never made the shift. You know, there are a couple of people who just decided, this isn't for me, this isn't what I want to be doing, and you know, they're not here anymore. And that kind of happens in software development when you make these kind of changes. So I hope that answers the question. I think in general, it takes people a couple of months to start getting comfortable. I think that it can take a long time to reach the point where you've actually encountered and worked with a sufficient amount of the framework and the functionality of OTP to really start getting across the board comfortable now. Does that make sense?
Yeah, absolutely. I think that answers the question, and obviously if there's any follow-up, we'll answer that in writing. Just to sort of give as many questions a chance, and thank you everyone again for asking all the questions we've received. Again, we will answer all of them, if not now, then in writing. But there are a couple of questions that are sort of moving through this general theme of Erlang adoption. So the next question, I guess, would be coming from William. Where would you and where would you not particularly use Erlang, based on your experience to date?
I'm trying to think if there's a place where I wouldn't want to use Erlang. So yeah, I think I would go with that. I think Erlang itself and OTP are something that we've never really had a problem with. We've never looked at a sector of our solution space and said, whoa, Erlang's a bad fit for that. I would not extend that to say that every aspect of Erlang and OTP is a perfect fit in every place. And I would especially call out, our bad experiences with Manesia. There are those huge disclaimers about using Manesia on networks that are not reliable and that have latency and things like that. And we didn't think we were, but when the code actually went out and got deployed, it proved us wrong. It showed us that we actually were putting Manesia out into places where we had an unstable network, and we began paying the price for that. So certainly there are places where certain technologies within the Erlang sphere are bad fits, but it's not that we could not have authored a wonderful solution in Erlang using its core feature set that could easily operate in that network environment. We just didn't realize what we were getting ourselves into when we did that.
Thank you for that. And just to try and honor as many questions as we can, I'll quickly move through the next few at least. And again, apologies to all those who will not have their questions answered now. So the next question comes from Tom. And Tom is asking, would you consider moving SIP RTP packet handling to Erlang?
That is a good question. We currently don't do a lot of that in our core product, but I think it would actually make an excellent fit for Erlang. I look at the huge success stories that Erlang has in the marketplace around asynchronous messaging and stuff like that, and think, building a SIP switch or something like that on Erlang seems like a very natural fit.
Thank you for that. Moving on straight to the next question. Fernando is asking, so in relation to your previous comments on Manesia, what storage technology do you then use for persistence when Manesia itself is not the best fit?
We are still using Manesia almost exclusively in the Erlang solutions that we're writing here. The part of Manesia that we're definitely shying away from is the clustering of Manesia nodes and the inherent trust of the underlying network that implies. However, that being said, we are employing the use of Elasticsearch, which is a Java-based NoSQL clustered storage facility. We started using that in one of our other products, and we're experimenting with its use in the new cloud offering of Callback.
Thank you for that, and I'll move straight on to the next question. We're officially over time that we would normally take, but because we've had so many questions, we should try and answer at least a few of them. So Dominic is asking, have you deployed Erlang in actual call centers, and was it difficult to make them accept that kind of solution in their production environments?
We have, and it was not difficult to get them to accept it, because we honestly didn't jump up and down and say, oh, by the way, this is Erlang. So we just sort of silently rolled that out as part of our 8.0, which was our high availability offering that came out a couple years ago. And the place where we did have some amount of acceptance issues was actually internally, and it was working with our support organization. We had tried to work ahead of time to say, hey, we're using this new technology with the high availability stuff, and we want to help you guys get up to speed with it and stuff like that. And they weren't jumping on that bandwagon, and when it did roll out, there was a little bit of pushback and backlash, because the Erlang solution behaved so differently than a traditional C++ application that it took some time for those guys to get up to speed with it and get a good feel for what was going on. So that's where we saw the backlash, I think, with that.
Thank you for that. I think that really answers the question. Now, we do have to finish the webinar at this point, but I do want to allow one further question because it really sort of stood out from the crowd, and it may be probably a good question to finish with. So the question is, was there one single unexpected benefit of using Erlang, something that really sort of stands out in your implementation of Erlang, something you did not expect, but that was a benefit that sort of just came up?
I'll tell you the thing that was really unexpected, and the thing that is so elegant about the Erlang runtime is the ability that you get to interact with the system while it's running. I've worked with systems that are interpreted, and I've worked with systems that have sort of a quasi-interactive shell, and I've worked in the Java space with JMX and stuff like that. But nothing beats the ability to fire up an Erlang shell, connect to a running node, and begin interacting with it to figure out what's going on that's right, what's going on that's wrong, making changes that you need to make, or even the ability to push out a modified module and dynamically reload that while the system's running. Those kind of things are just crazy powerful and completely unexpected when we got into this. I don't think anyone could even have imagined that we were going to be able to do stuff like that with the Erlang platform when we first started writing code with it.
Thank you for that. I think that's really inspiring and a great response. So I do apologize to everyone asking all the questions that we haven't managed to address, but I would say I know that everyone will join me in thanking yourself, Brian, for a fantastic talk on your implementation of Erlang in call center operations, and many thanks to all of you who have joined us for the webinar as well. Please join us for our next monthly webinar. And following today, just to say, we will be sending you a short survey to make sure we capture your feedback of today's webinar. Please note that the recording of the webinar and the presentation that was shared today will also become available for you to collect on Erlang Solutions' corporate website, which is www.erlang-solutions.com. I would like to mention, though it may be a bit late, that at the moment we are running our Erlang user conference in Stockholm. That's from the 11th to the 12th June. If you do have a chance to visit it, then please do. It is the oldest and the largest Erlang conference in Europe, a perfect place to hear some compelling cutting-edge Erlang talks and mingle with Erlangers. So please do that if you can. Just to say once again, thank you all for attending the webinar. We very much